For our final speaker this evening, or this afternoon, I'd like to welcome Dr. Patrick Byrne, who is a professor emeritus now at Boston College and who probably needs very little introduction to many of you. Dr. Byrne has recently authored two especially important books in relation to environmental ethics, the first being his Ethics of Discernment, and the second being his, if I may, Towards Environmental Wholeness, which just came out last year?
March.
March, okay, yeah, March of this year.
Well, no, actually.
Of 2024, right? Yeah, okay. Okay. I was going to say, just came out 2 minutes ago. Run. So without further ado, I'll give you Patrick Byrne on the integral ecology, the crisis of trust and hope. And I'm just going to start the recording.
Thank you, Ben. And I would like to thank the organizers of this colloquium for inviting me to speak today. The stated theme of the colloquium is a renewed reflection on the notion of integral ecology on the 10th anniversary of Pope Francis's monumental Laudato Si. The organizers invite us to explore how this renewed reflection is aided by Bernard Lonergan's lifelong efforts to provide a method that can facilitate interdisciplinary collaboration across the fields, both theoretical and practical, of the natural and human sciences, extending to the inclusion of contributions from philosophy and theology. In doing so, the organizers have invited us to reflect especially on the importance of the word integral in Pope Francis's notion of integral ecology. I'm especially grateful to Ben Homan, who asked me to speak about my recently published book. In that book, I do endeavor to show precisely how Lonergan has provided a method that can facilitate interdisciplinary collaboration across those fields. So as a prelude to my main talk on integral ecology, the crisis of hope, the crisis of trust and hope, I'd like to offer a very brief overview of my book. And I'm grateful to Henry Whitcomb for having done a lot of that work for me in his previous talk. The concluding chapters of my previous book, The Ethics of Discernment, I argued that the method Lonergan worked out for theology is also a method for ethics more generally. His is a method for critically receiving what has been passed along to us by those who came before us, which is linked also to a method for ethically responding to the challenges of the present for the sake of the future. Not sure that's all that clear from reading Method and Theology in itself. So Lonergan's is a method of what he called the 8 functional specialties, in which critical appropriation of the history plays a crucial role. Since I was writing about ethics as a philosopher and not as a theologian, I followed Lonergan's own suggestion that this method could be profitably adapted to the fields beyond theology by transposing the last 3 functional specialties, doctrines, systematics, and communications, to policy, planning, and implementation. So the first 3 things are it's not as though historians do history. Historians do the first 3. Lonergan's own specific contributions to this come at what he called dialectic and foundations. As I try to show in the book, lots of people have been doing planning, policy planning and implementation. Particularly, I make the argument that Laudato Si is an example of that, as is the United Nations Sustainable Development Goals process. So Lonergan really was aiming at integrating lots of collaborative things, lots of things that people are doing into a framework where their mutual reinforcement of one another could become apparent. The chapters of my book are organized, whoops, wait a minute, what did I do here? Oh, yeah. When I began teaching courses in environmental ethics, I realized that this field would benefit from Lonergan's method. Historian Spencer Weir has emphasized the importance of understanding the history of science as a basis for ethical response. And Lonergan's method provides a framework for carrying forth his exhortation. Hence, the chapters of my book are organized along the lines of his 8 functional specialties, though not in a rigid or sequential fashion. Here I've highlighted in blue the chapters that are primarily historical, those in red that are dialectical, in green the chapters that engage in foundations, and in purple those that make connections with policy, planning, and implementation. And again, my gratitude to Henry for spelling out a lot of the content of the book in a very precise and succinct fashion. Why did I write the book? The book was at press in June of let me back up here. The book was at press in, I think, September of 2023. Came out in hardback in March of 2024. If the book had come out a year later, I would have to revise a fair amount. But just why did I write the book? I just want to read this one paragraph from the introduction. Although the election of President Biden, the U.S. return to the Paris Agreement, and the reversal of many of the Trump-era policies were important events favoring one strong side of the conflict, the underlying culture of climate change denial and of opposition to environmental protections has not gone away. These conflicts need to be addressed on many levels. While I personally side with those who affirm the reality of the grave threats to our planet and the ethical urgency for appropriate actions, this book contends that it is just as important to attain critical understanding of the underlying ethical reasons for these claims. This book therefore endeavors to address some, but certainly not all, of the deeper philosophical and cultural issues that would contribute to attaining this critical understanding. The ominousness of what happened since that book went to press is looming strongly before us now. But I still think the critical understanding is important. Much more, many other kinds of things, of course, are absolutely indispensable. Everybody who spoke today is talking about the urgency and the diversity of responses that are needed. My book is hopefully one small contribution that's certainly not, perhaps necessary, but certainly not sufficient. Okay, against this very brief introduction to the book itself, I'll now turn to my presentation today on integral ecology, the crisis of trust and hope. I'll draw upon some parts of my book, but also go beyond it because the book was deliberately limited to be a philosophical work, and today I'm going to take up some theological issues. I will emphasize the importance, but also the difficulties of integrating interdisciplinary work, both in achieving understanding as well as caring for our planet. I'll then explain what I think both Lonergan and Laudato Si have to contribute to those monumental tasks. Specifically, it might seem that there can be no real conversation or collaboration among the sciences and theology. For, it will be objected, the natural sciences, like ecology and climate science, deal with scientific facts, whereas theology is merely a matter of beliefs that cannot be empirically verified. In my presentation, I will argue that this objection is founded on an untenable set of assumptions about science. Science in general, and assumptions that are especially untenable for ecological and climate science. As these fields of scientific research developed, they revealed the great dynamic complexities of the planet Earth. This degree of complexity presented the need for an integral, holistic framework that could bring together the diverse findings from the numerous scientific disciplines. In order to meet this challenge, scientists had to believe and trust other scientists outside their fields of expertise, contrary to the assumption that belief is inimical to objectivity in science. I'll show how the indispensable presence of trust and belief in the practices of the science therefore opens the door for a fruitful conversation and collaboration with theology. In addition, years of ecological and climate change science revealed real-world situations that call for urgent actions. This has confronted us with the need for a still wider integral framework that could integrate scientific knowledge with responsible human actions. I will show how further contributions both from philosophy and theology have arisen to meet this challenge. In particular, I will show how Pope Francis's Laudato Si and the work of Bernard Lonergan and my own extension of his work have contributed to the task of forming a framework for integral interdisciplinary efforts. The need for these kinds of reflections is especially acute today because of the growing crisis of trust regarding science. Climate science denial received its original powerful impetus, in 1989 from the Presidential Chief of Staff, John Sununu. He used his powerful position to publicly cast doubt on the certainty of climate science. He repeatedly interfered with and even silenced government officials who were trying to implement policies to address the problem of human-caused climate change. He undermined efforts of U.S. officials to join international initiatives to address climate change. He even forced scientists who were working for the government to alter the reports of their research. Those who had long been opposed in principle to all forms of government regulation now seized upon Sununu's new strategy. Rather than attack climate change policies because they were allegedly interfering with the free market, their new approach was to attack climate change science itself on the basis of its uncertainty. Sununu's bold steps stimulated an exponential growth of a worldwide network that adopted the strategy of creating distrust in science itself. This network is a well-funded, highly complex, and relatively coordinated denial machine that comprises fossil fuel corporations, numerous institutes and associations funded by them, conservative philanthropists, foundations and think tanks, front groups, contrarian scientists and their institutes, and media outlets in coalition with certain elected officials. Its mission has been to undermine trust and belief in climate science by emphasizing the lack of absolute certainty in scientific findings. This is a grave crisis of trust in need of an even more complex and deeper interdisciplinary response. And it goes perhaps without saying that what began as an undermining of trust and belief in climate science has burgeoned outward into other sciences in ways that are quite alarming today. Nevertheless, today, a great many people do trust public statements made about scientific findings regarding the environment and climate change. However, this tends to obscure the significant challenges that had to be overcome during the histories of the ecological and climate change sciences, challenges that arose out of the complexities of the environment and climate themselves. The science of ecology emerged out of the sometimes overlooked science of botany, where some botanists took the bold step of moving out of their laboratories to undertake field studies. These field studies focused on the complex interactions among plants in widely different habitats. The new field botanists had to develop new methods that would convince more traditional botanists of their objectivity of their work in environments where the control of variables could no longer be guaranteed as easily as they could in laboratory settings. Soon after they demonstrated the legitimacy of their methods, field botanists realized that they had to take into account ever wider ranges of natural phenomena beyond plants alone. First, the science of animal ecology began to grow independently alongside plant ecology. Then scientists had to solve the problem of synthesizing the methods and findings of both botanical and zoological ecological studies. Next, ecological scientists had to work on incorporating the findings from physics and chemistry regarding air, temperature, water, rock, minerals, and soil. The results of these studies gradually forced the abandonment of an idea of nature as an unspoiled, unchanging realm. The initial steady-state model of the natural environment was replaced by a succession of ever more dynamic and complex ways of integrating the research findings of the diverse sciences. The first was called the organic model, and it arose from studies of prairies and grasslands in the Western Plains. According to the organic model, plant succession develops toward a stable, adult, and relatively permanent population called a climax community. But subsequent studies revealed that many natural biotic communities do not always develop toward some single organic whole, and that most environmental processes are never complete, because even modest changes in water, soil, chemicals, or temperature affect the dynamic pathways of the biotic environments. In the 1930s, Arthur Tansley therefore coined the term ecosystem to replace the organic model for environmental studies. For Tansley, the whole system, in the sense of physics, including not only organisms complex, but also the whole complex of physical factors, needed to be studied in their complex interactions. At first, ecosystems were elaborated along the lines of food webs and pyramids, where the large numbers of organisms at the lower level supported smaller numbers at the upper layers. More recent developments in complex dynamic systems theory have provided further technical elaborations of the meaning of ecosystem. In this approach, the various elements within an ecosystem are integrated not simply in a linear and causal way, but also in more complex ways characterized by feedback loops. The study of ecosystems then began to focus on how nonlinear feedback loops operate within populations in nature. Out of this research, two newer models emerged, the community model and the energy model. Understanding ecosystems as complex, dynamic integrations of diverse scientific findings has continued to develop to the present day. Now, something similar can be said for the challenge of integrating researches from diverse sciences in the field of climate change. Again, to quote Spencer Weir, orbital changes, wind patterns, melting ice sheets, ocean circulation, everything seemed to be interacting with everything else. During the 1960s, not only climate science researchers, but also scientists in other fields and members of the public were coming to recognize that the planet's environment is hugely complicated structure. Almost any feature of the air, water, soil, or biology might be sensitive to changes in any other feature. This all began with a careful study of anomalous rock formations by geologists in the 19th century. These studies gradually led to theories about millennia-long sequences of ice ages. Questions about the causes of ice ages led to Arienhus's insights into the possibility that variations in water vapor and carbon dioxide could result in atmospheric heating and cooling, possibly causing the ice ages. This led to researches into the absorption of different waves of infrared radiation by carbon dioxide. Using the 19th century physics regarding laws of heat and fluid flow, 20th century scientists began to incorporate ever more complex factors and feedback phenomena into their studies of climate dynamics. The laborious work of computer models gradually incorporated ever more components in order to arrive at increasingly accurate depictions of climate dynamics. Among other things, they had to convince scientists what they were doing was legitimate empirical science. To their initially crude models, they gradually added further environmental factors that led to a more complex, layered model of climate reality. The interactions between ocean and atmospheric dynamics, such as calcification and acidification, were incorporated. These were followed by the inclusion first of more realistic differences across the Earth's topographies, then of living ecosystems, and finally projections of human population growth and economic development. Although countless research findings from many diverse sciences contributed to the judgment that atmospheric warming is indeed being caused by human industrial activity, perhaps none was more important than the remarkable precision in the measurements of rising carbon dioxide levels in the atmosphere atop Mauna Loa by Charles David Keeling. Regarding the assembly of this vast array of scientific findings, Weir wrote, "It was not the weight of any single piece of evidence that convinced them, but the accumulation of evidence from different independent fields, increased haze and jet contrail clouds, ancient catastrophic droughts, fluctuating layers in ice and seabed clays, computer calculations of planetary orbits, and energy budgets of ice sheet collapse. Each told a story of climate systems prone to terrible lurches. Each story, bizarre in itself, was made more plausible by all the others." Part of my book is to show how Lonergan helps us understand the relationship between scientific knowledge and ethical response. I begin with some reflections on the problem of the is-ought bifurcation or separation that became very powerfully present in our culture through the work of David Hume, and to show how Lonergan's understanding of reasoning, where ethical reasoning is a continuation, not an opposition to our understanding of scientific facts, how he helps us think about that, and therefore to think about how what we know about the world on the basis of scientific knowledge is relevant to and the foundation for our ethical response. It's unlikely that computer models will ever capture all the rich complexity of the dynamic relationships among the Earth's constituents, something that most computer modelers themselves readily admit. While their efforts to find an integral structure that took seriously and incorporated so many diverse components gave them credibility, the enormous challenge of this complexity also pointed to the need for contributions that lie beyond the methods of computer modeling as well as the natural sciences. As historian Eugene Cittadino put it, the new environmental movement began drawing heavily upon the science of ecology for inspiration. This was a role that some ecologists may have relished, but for which most found themselves either unsuited or inadequately prepared. The science was itself incomplete, imprecise, and conceptually inconsistent. Ecology could only offer limited assistance towards solving environmental problems, not only because of the enormous complexity of the problems themselves, but also because the solutions required complex value choices that transcend the boundaries of their sciences. To summarize this section of my presentation, the dynamic complexity of the Earth has posed an enormous challenge for scientific understanding. To meet the challenge, the sciences first had to develop ever more specialized methods to correctly understand the diverse components of the complex ecosystems and climate dynamics. Many of these specialized scientific results in turn set further challenge for reintegrating the specialized findings into a whole that does justice to the reality of the planet's dynamic wholeness. This required scientists to step outside of established specialized methods to forge new kinds of methods. The achievements of computer modelers especially have gone a long way toward addressing this challenge, though they themselves recognize the limitations of their work so far. In addition, as Cittadino points out, these achievements point toward the need of something further, both because of the complexity of the planet itself, but also because of the solutions required complex value choices. The methods of the natural sciences are not designed to meet questions of value and policy actions. In the next section, I will quickly survey how some philosophers have contributed to addressing these issues that transcend the methods of the natural sciences. The complexity of environmental and climate phenomena calls for contributions from a great many diverse sciences. But what is lacking from the meticulous findings of each of these sciences, and even from all of them taken collectively, is a well-grounded integral understanding of how the diverse findings are interconnected. This is because no one scientific specialist can know what all the other scientists know on the basis of their training in their own specialized methods. The history of environmental and climate change science shows how difficult it was for a few resolute scientists to move out of their specializations toward forging interdisciplinary integrations. They did not accomplish this by attempting the impossible task of learning everyone else's specialized methods. They did not do so by becoming specialists themselves in all the other requisite disciplines. How they did arrive at some integral vision is the topic of my next section. But before turning to that section, I wish to explore how philosophers also made contributions toward formulating a holistic view of the earth, one that would connect the findings of the sciences to values that can guide human actions in response to that knowledge. In particular, I will show how Bernard Lonergan's philosophy, grounded in self-appropriation, can offer a way of thinking about the wholeness of the dynamic planet in ways that the natural sciences cannot. In my book, Toward Environmental Wholeness, I rely largely on the work of Joseph Desjardins to trace how philosophers took up the challenge of thinking ethically about the environment as a whole. He narrates how the environmental critical thinking was first conducted along anthropocentric utilitarian lines. Gradually, however, questions and concerns pushed thinkers beyond human-centered utilitarian limits toward more holistic frameworks. Throughout the 20th and early 21st centuries, numerous thinkers endeavored to achieve a coherent ethical account of the greater environment as a whole. These efforts first argued that sensate animals had values in themselves that were not reducible to their worth in serving human wants and needs. Thanks to Jim for making that point so powerfully this morning, or earlier today. Other thinkers pushed beyond sensate animals, arguing for the value of all life as a whole. And later thinkers argued for the value of still more comprehensive wholeness that incorporated non-living geological, atmospheric, and water constituents of the ecosystem. Desjardins shows how these efforts struggled to incorporate ever wider human realms, and how they also tended to denigrate the value of human beings in correspondence. Understanding humans as full participants in planetary environment, neither as overlords nor as parasites, has posed serious challenges to holistic philosophical thinking. Finding a vision of wholeness that does justice to all the complex realities of nature as disclosed by scientific research, inclusive of both human as well as non-human actors, has become ever more problematic. In my book, I show how Lonergan's analysis of generalized emergent probability and his method of 8 functional specialties have something of importance to offer to this set of problems. Generalized emergent probability is not a theory. It is rather what he calls a heuristic structure for bringing together the findings of diverse sciences, both natural and human. It arose out of Lonergan's brilliant intentionality analysis of the methods of the sciences and their implications for a holistic view of the universe that can be known through those methods. As such, generalized emergent probability focuses on the emergence, development, transformation, and demise of schemes of recurrence in nature. The events that make up the schemes of recurrence and sequences of development are related to one another in accord with what Lonergan called the classical laws discovered by physicists, chemists, botanists, and neuroscientists. The conditions under which the schemes and developments emerge, thrive, or perish occur in accord with scientifically verified probabilities. These diverse findings can be integrated by means of the rubric, this is a quote from Lonergan, classical laws tell what would happen if conditions were fulfilled. Verified probabilities tell how often such conditions are fulfilled. Indeed, Lonergan's peculiar phrase, this is another quote, flexible circle of ranges of schemes of recurrence reflects the dynamic complexity found in ecosystems and the climate. Now, generalized emergent probability cannot substitute for the meticulous and creative research of thousands of scientists. Generalized emergent probability cannot determine the specific details of schemes or developmental pathways or probabilities that have to be discovered and verified through long and hard scientific research. But generalized emergent probability does provide a comprehensive framework that helps bring together the findings of the diverse sciences into a whole where ecosystems emerge, develop, are transformed, and perish. In my book, I also drew upon Lonergan's account of the ontology of the good to show how the dynamics of generalized emergent probability can be more properly and completely understood as a dynamic emerging good. I show how authentic human thinking and acting can, and often does, provide a continuation of the natural emerging good. Insofar as humans intelligently, sensitively, and responsibly bring forth ever more intelligible and valuable schemes and developments, they participate in continuing the process of the emerging goodness. In this way, generalized emergent probability and the notion of the emergent good provide a holistic vision of the combined value of the natural world and ethical responsibility that humans bear toward it. Of course, there's countless ways in which we human beings have violated the normativity of the emerging good by acting unintelligently, insensitively, and irresponsibly, and thereby have corrupted the dynamic emerging good into what Lonergan called the social surd. Human beings, one time he said the social dump. Human beings, therefore, take their places as actors in history, take their places as actors in the emerging good that was already going on for billions of years before us. But this is not the kind of story found in a Disney movie. It's a story with an upwardly but indeterminately directed dynamism, as Lonergan put it. Because the story of the emerging good is both indeterminate and directed, again quoting Lonergan, it neither denies nor minimizes the facts of entropy, cataclysm, the death that follows every birth, the extinction that threatens every survival. It offers no opinion on the ultimate fate of the universe, but it insists that the negative picture is not the whole picture. Cataclysms and extinctions were intrinsic episodes of the story of the emerging good long before human beings came along. But we brought and added our even darker cataclysms and extinctions through horrific, sinful acts toward each other and the rest of nature. These, too, are parts of the complex story of the emerging good that cannot be ignored. These facts point to the still further need for theological contributions to forging a holistic framework adequate to the task of integrating the diversity of scientific researches with the diversity of human ethical actions. And so now science, belief, and trust. I endeavored to show how Lonergan's analysis of generalized emergent probability and the emerging good contributes to the philosophical efforts to formulate a vision of wholeness. In this section, I consider the possibility of a still further theological contribution. Now, some people may well wonder, in fact, some have said, that Laudato Si is an unwarranted intrusion of religious belief into the field of scientific fact. They may assume that belief has no place in science. It is on this basis that they attempt to refute climate science deniers. The deniers, they say, rely on beliefs, not on hard scientific facts. Frequently, scientists and others have responded to the deniers by confronting them with the facts that are already out there for anyone to see, assuming that this will overcome their denial. But as climate scientist Katharine Hayhoe has argued convincingly, this strategy has been ineffective. In part, this is a big mistake. It is a big mistake to assume that belief should have no role in science. Contrary to this widely shared assumption, belief is essential and indispensable to the conduct of scientific research. Ignoring this fact has weakened the attempts by both scientists and non-scientists alike to refute climate change denial. Ignorance of the role of belief in science has led to blindness about the serious and deep crisis of trust that underlies science denial. Lonergan observed that science is often contrasted with belief, but the fact of the matter is that belief plays as large a role in science as in most other areas of human activity. At the earliest stages of their formation, science students trust their teachers and textbooks and lab manuals. Trust and belief at this early stage provides them the space and time to do the hard work of acquiring thousands of insights that they will need in order to understand the ideas, theories, and methods that have been bequeathed to them by previous generations of scientists. They need this so that they can engage in their own scientific research. Scientists also trust suppliers of lab equipment, instruments, reagents, and specimens. Although they do test some samples of those items supplied, they do not and cannot test each and every item. Otherwise, they would have no untainted items to use for their experiments. More importantly, scientists also trust one another and believe the results reported by other scientists. Lonergan points out that scientists do not spend their lives repeating one another's work. They can only make their own contributions by believing the reported results of others to be true, or at least to be probably true. They believe the results of others and build upon them by adding their own further insights and observations, thereby corroborating or correcting the inherited scientific insights and results. While it is true that some scientist somewhere does herself or himself have direct, imminently generated knowledge of some particular scientific fact, no one has direct knowledge of all the facts that scientists have discovered about the environment or climate change. Scientists trust one another to be honest in reporting what they know and what they do not know. Even more do they trust the institutionalized vetting processes, such as refereed journals, conferences, and what Spencer Weir calls the flexible, freewheeling groups that scientists have perfected over centuries. These institutions keep scientists honest and expose deviations from proper scientific procedures. Believing, therefore, is indispensable to the scientific enterprise. More importantly, believing relies on trust. Again, Weir describes the intricate process. For the process to work, scientists must trust their colleagues. How is this trust maintained? Telling the truth is important, but it is not enough. Although scientists rarely cheat one another, they easily fool themselves. The essential kind of trust comes from sharing a goal, namely the discovery of reliable knowledge, and from sharing principles and methods about how to pursue that goal. This trust is earned, but trust itself does not result from scientific experiments. Even so, such trust and belief are not necessarily unreasonable. Parallel to the self-correcting cycle of imminently generated knowledge that Lonergan described, he also identified a self-correcting cycle of critical trust and believing. This process is reasonable because it engages in the ever further questions about whether one should trust person P who is claiming that fact F is true, or at least probably true. Taking seriously the retinue of questions and withholding the decision to believe until these and all further relevant questions have been answered satisfactorily. These together constitute what is reasonable critical believing. Independently of Lonergan, Wirt describes the importance and the challenge of achieving and maintaining critical trust in climate science. Maintaining trust is more difficult. A community in one specialty cannot thoroughly check the work of researchers in another, but must find a few people who seem reliable and accept their word for how to view the latest results. The study of climate change is an extreme example. Researchers cannot separate meteorology from solar physics, pollution chemistry, and so forth. The range of journals they cite in their footnotes is remarkably broad. So many different factors influence climate, but this complexity imposes difficulties on those who try to reach solid conclusions about climate change. Establishing a level of reliability depends on a process of checking and correction by dozens of scientific communities, each dealing with its own piece of the problem. Scientists, therefore, were able to achieve their integral visions of the environment and climate change not on the basis of a philosophical framework, but on the basis of trust. Over the course of a century, they trusted a diverse range of other scientists and believed their reports of research findings. This process culminated in the work of the computer modelers, who trusted and believed the numerous findings of diverse scientists that they used as inputs into their computer models. In turn, other scientists trusted the algorithms devised by the computer modelers that they were reliable. At bottom, the non-philosophical integration of diverse scientific findings into the claims about the environment and climate as a whole was affected by trust. Critical trust and critical belief, therefore, are indispensable to science. This is why the rise of climate science denial and the subsequent waves of science denial in general is so pernicious. The indispensable need for belief and trust in science means that religion and theology are not a priori incompatible with science merely because one depends upon belief and the other does not. Nevertheless, religious belief cannot and should not replace scientific findings or scientific belief or trust. In addition to scientific beliefs, religious beliefs and theology have something independent and distinctive to add to the process of forging an integral vision of wholeness. Religion and theology can contribute something further that complements the massive scientific work as well as the philosophical and ethical responses to those scientific findings. In particular, Laudato Si has something of great importance to contribute toward meeting the crisis of trust at the bottom of science denial. In my book, I show how Laudato Si mirrors some of the functional specialties that Lonergan developed for his theological method. Like Lonergan's theological method, Laudato Si provides a framework for bringing together the diverse contributions in caring for our planet. I should say, I'm not sure I should place, maybe I should say our home, caring for our home. Its opening paragraphs are explicitly and deliberately addressed to the need for contributions from every person living on this planet. Pope Francis invites everyone, not only Catholics, to enter into dialogue about our common home. Importantly, the penultimate chapter of Laudato Si is entirely given over to invitations and guidelines for several new kinds of dialogue about how to meet the challenges posed by the degradation of the environment and by climate change. That chapter proposes dialogues between science and religion, as well as dialogues about economic and political matters at the international, national, and local levels for the sake of effective cooperative actions to protect and promote the natural world and human dignity. In the encyclical, Pope Francis calls for a collaboration and trust in a collaborative effort to overcome the toxic atmosphere of mistrust at the root of environmental and climate science denial. His call to dialogue addresses the question posed by climate scientist Katharine Hayhoe. She asks, what's the most important thing we can do about climate change? Her answer is to talk about it with others. She has found over and again that genuine dialogue with people on a personal level about concrete things of shared value is most effective in overcoming mistrust and communicating about why we are concerned about climate change. Of course, the kinds of dialogues to which Pope Francis invites people were already underway to a large extent before Laudato Si was promulgated. Yet Pope Francis proposes his own Catholic tradition has something of special importance to contribute to these dialogues, namely its understanding of creation. Creation is something, and creation is, of course, something that's shared by other religious traditions. And quoting from Laudato Si, in the Judeo-Christian tradition, the word creation has a broader meaning than nature, for it has to do with God's loving plan, in which every creature has its own value and significance. Most people are alarmed about climate change and environmental degradation because of their impacts on human beings and our ways of life. These concerns do provide powerful motives for working to mitigate climate change and adapt to its oncoming impacts. But while concern for the threats to human ways of life is extremely important, it's not completely holistic view. Without a vision of the wholeness that includes but goes beyond human wants and needs, the actions that are undertaken will lead to distortion because of those omissions. By way of contrast, in bringing the notion of creation into the dialogues, Pope Francis is setting forth a vision of the whole universe as an outpouring of the blazing creative love poured forth from a gracious and benevolent God. To the extent that people bear in mind that every created entity, no matter how small or great, is a gift endowed with a sacredness that flows from the infinite understanding and goodness and love of God, to that extent they will be motivated to carefully understand, reverence, and respect the value and significance of all creatures. With this spirit in mind, people will interact with and make prudent use of the entities in the natural world with an awareness of their profound value. Being mindful of creation, of course, likewise means that human beings are also to be treated with their proper dignity, something that has been repeatedly violated in the actions whose impacts on the environment have had their worst consequences for the most vulnerable of human beings. Perhaps only the great poets and mystics among us live with constant awareness that every single temporal thing in the world bears the stamp of God's infinite love. The rest of us retreat into the worlds of our limited daily concerns most of the time. Pope Francis and St. Francis before him recognized the importance of constantly reminding the rest of us that God saw the whole of creation as very good. The non-mystics amongst us need these constant reminders if we are to truly understand the emerging goodness of creation in all its depths and to authentically respond to that integral goodness. This complex network of relationships between the Creator God, the natural ecosystems. Wait a minute. Not sure if I lost my place here. Sorry. Is what Pope Francis calls integral ecology. Although technically speaking, ecology is the name of a scientific field, the integral ecology of Laudato Si is not a new science, but an expanded holistic framework for integrating human actions with the results of science. Thus, integral ecology is the centerpiece of Laudato Si because, as Pope Francis argues, if one of the three relationships is out of kilter, this brings damage to the relationships of the other constituents as well. In addition to the notion of creation, there's something else from the Catholic tradition that is of utmost importance in forging a holistic vision of the planet, namely the specifically Christian understanding of hope. While Pope Francis does not give hope the same prominence as the notion of creation in Laudato Si, it does appear over a dozen times in the encyclical, and most emphatically in the following passages, quote, "May our struggles and concern for this planet never take away the joy of hope," and "How wonderful is the certainty that each human life is not adrift in the midst of hopeless chaos, in a world ruled by pure chance or endlessly recurring cycles." Pope Francis was much more discouraged 8 years later in his sequel, Laudate Deum. Yet even there, he still called for hope. Quote, "Although our days seem to be showing signs of certain regression, each new generation must take up the struggles and attainments of past generations, while setting its sights even higher. This is the path. Goodness, together with love, justice, and solidarity, are not achieved once and for all. They have to be realized each day." And again, another passage, "It is hoped that a multilateralism from below, and not simply one determined by the elites of power, will happen with respect to climate crisis." There are, of course, many forms of hope. Scientists undertake research projects in hopes that they will come up with verified hypotheses and theories that explain some part of natural or human reality. Non-scientists undertake many sorts of efforts in hopes of helping loved ones, neighbors, people in distress far away, and the planet and its ecosystems. These are normal and beneficial hopes. But the Catholic tradition, shared by other religious traditions as well, also attests to a form of hope that is beyond all human imagining. This is the hope that St. Paul proclaims when he wrote, "We boast in hope of the glory of God. Not only that, but we even boast of our afflictions, knowing that affliction produces endurance, and endurance, proven character, and proven character, hope. And hope does not disappoint, because the love of God has been poured out into our hearts through the Holy Spirit that has been given to us." This form of hope is also of the utmost importance for reintegrating the findings of ecological and climate change sciences with responsible and loving human actions. On the one hand, when we are confronted with the dire scientific predictions about the massive perils to our planet by the environmental degradation and climate change, it will seem that our own individual efforts can never be enough. So Richard gave us plenty of what those dire predictions are, and ended on a note of hope also. The overwhelming magnitude of the complexity of the planet can make even the most, almost any finite scientific finding seem inconsequential. On the other hand, the intransigence of climate change denial and its exponential growth of political power can lead to despair on the part of people who are attempting to take steps that decrease the human-caused human-caused emission of greenhouse gases into the atmosphere. It can even lead to despair on the part of the environmental and climate scientists when it seems that no one is listening to them anymore. As Deborah Rienstra reports, "The more time I spend with my science colleagues, the more I feel their sadness." These overwhelming phenomena tempt people to give up in despair, since it seems that nothing we can do will make a difference. This, I believe, is where Christian affirmation of hope has something to contribute that is indispensable. Certainly many scientists and activists who do not profess Christian or any religious belief do act in hope that what they are doing will matter. But long years of frustration can inevitably wear away at that hope. The hope to which Laudato Si and religious people in general give witness is a hope that resists this deadly, erosive power of despair. It is a form of hope that manifests itself in people who persevere, knowing full well that the odds are stacked against them. It is a hope that, in spite of what things look like to finite human understandings, God really is bringing the vast diversity of dedicated human efforts and of scientists and activists and ordinary people together into a whole goodness. It is a hope that God is actively composing a story of goodness that is integrating all the intelligent, sensitive, and responsible and loving efforts into a whole. The gospel quotes Jesus' promise, "When I am lifted up from the earth, I will draw everyone to myself." It is a hope in God's story, which will only reach its completion long into the future, but nevertheless cannot be fully realized without human, authentic contributions, even in the face of dismissal and ridicule by others. It is a hope in what Gregory Boyle calls the slow work of God. It is a hope it is a hope for people who no longer see their efforts can make a difference. As Deborah Rienstra puts it, by fulfilling our healing vocation, we participate in the long arc of God's redemptive plan, which culminates, we hope and believe as best we can, in an ultimate flourishing for the whole community of creation. It is very timely that this Jubilee year, calls people to be pilgrims of hope. This is a hope that motivates people to persevere in difficult scientific research and responsible actions when things seem hopeless. But this is not a complacent hope. What Pope Francis is talking about, what St. Paul is talking about, is not a complacent hope. It's not a hope where people sit idly by and expect that God will somehow eventually make everything come out all right in the end. It is rather a hope that inspires constant perseverance against great odds, both in scientifically unraveling the complexities of nature and working against the mean-spirited ignorance and selfishness that resist the hard choices that we have to make. It's a persevering hopefulness that God will accomplish the integral good through the hopeful efforts of countless human beings who continue to understand and act in fidelity to the structure of ethical intentionality, especially as guided by unrestricted being in love. It is a hopefulness that their small acts do matter and that God will take them up and integrate them into a whole that we can neither imagine nor accomplish on our own, a good that we can now see only as through a glass darkly. It is, to adapt Lonergan's phrase, an upwardly but indeterminately directed hope. In conclusion, in this essay I've taken up the question of interdisciplinarity, of how the various contributions of the sciences, philosophy, and theology can be brought together in ways that are fruitful and rationally defensible. I have argued that many diverse scientific specializations have evolved in the endeavor to correctly understand the dynamic, incredible complexity of our planet's environment and climate. I further argued that this multiplication of specialties created the need for frameworks of integration in order to bring the vast diversity of research findings together. I further argued that the sciences themselves are not designed to solve this problem, and that philosophy, especially Lonergan's notion of generalized emergent probability and its extension into the notion of the emerging good, goes a long way toward meeting this challenge. Yet scientists themselves made important contributions to unifying their diverse findings on the basis of their thoughtful belief and trust in one another. The attacks on trust in science have revealed the need for specifically religious and theological contributions to the scientific and philosophical efforts to address the crisis of environmental change, to address the environmental crisis. In particular, Pope Francis's Laudato Si has shown how religious practices and theologies of creation and hope make critical contributions to the interdisciplinary collaboration and integration that is needed to address this crisis. Thank you.
Questions?
Thank you very much, Professor Byrne. That was excellent. I think I'm a theology professor, and a number of students here, undergraduates, are here. And I'm curious to know, how much do you think, how much does the possibility that the world will come to an end because of the climate crisis should condition our behavior vis-a-vis the world? And I'm trying to do like an imaginative empathic exercise. You go on Twitter, you see videos of people saying the world will end by 1992 unless we do action tomorrow. The world will end by 2008 unless we do action. The world will end by 2020. There's almost like a millenarianist like fervor, like the world's coming to an end and we need to act. And then people say, well, it didn't end. I guess this isn't really an issue. And I wonder if that doesn't kind of contribute to a certain skepticism. And so I guess my point is, should concern for the globe and care of it be contingent on what the latest kind of fervor is around the possibility that we are going to bring an end to the world?
Well, let me take the questions in kind of reverse order.
Sure. Yeah.
Should our hope and should our efforts to care for the world depend upon the doomsday scenario? No. Part of Laudato Si is calling us back to something that always has been and always should have been part of our living human lives in this, I want to say, I don't know whether to say planet or Earth or home, but on this planet, let me say. Okay. So should it depend on that? No. What it should depend upon is our own intrinsic dynamic of what goes on when we make decisions. What goes on when we make decisions is we ask, what is the situation before us? And to a large extent, that's what science of the last century has been telling us, that there are things about the situation that we're in that we wouldn't know just on the basis of our common sense knowledge. Our common sense knowledge is being supplemented by scientific knowledge. This is our situation. Now that we know something about that situation, we have questions about, well, what can be done and what should we do? That's a large part of what I tried to develop in the book. That's something that was happening before there was climate change, except the climate's always been changing, but before the human-caused climate change that we're talking about now. That's something human beings have always done. So Laudato Si is really calling us back to be the human beings that we have been, and to stop ignoring the questions that we don't want to face, and to stop ignoring, engaging in kind of fantasies about the situation, and to stop ignoring the difficult choices that we have to make, and that we have to make together, not just individually. So should it depend on that? No, it's calling us back to something that human beings at their best were always doing, and interiorly that we know we're called to do, but we don't always do it very well. Okay. The other thing I wanted to address, so my friend Deborah Rienstra, her book is entitled Refugia Faith. And I really recommend it to everybody. She's a professor of English at Calvin College, and she makes the argument that we have talked about stewardship for the planet Earth, and as beneficial as it has been to talk about stewardship and to shift away from having dominion over the Earth, we really need to think about something else. And so she was thinking about different kinds of symbols, and the symbol that she picked up is refugia. Refugia is a term from biology. Refugia are the little spots in places on the Earth where there have been enormous environmental disasters. So think of the Mount St. Helens eruption, or think of the Indian Ocean tsunami, where devastation has just been widespread and catastrophic. The world came to an end, except it didn't. Biologists who study refugia study the places where life comes back. The little place that maybe one little rock was pitched over to protect this little seedling from being devastated by this disaster. And so the book is an exploration of how to think about our hope in terms of refugia. My book, I focus mainly on the concern with mitigating climate change. But if we stop putting carbon dioxide into the atmosphere right now and never put another a molecule of carbon dioxide into the atmosphere, atmospheric warming and complex climate dynamics will continue for at least another century. So we need to also think about how to respond to the oncoming changes that are going to be very disastrous in many cases. That does not mean that the planet's going to be destroyed. That there are refugia. There are refugia for the natural world to come back. There are refugia for human beings. But we can't be naively optimistic and say, oh, we don't have to worry about things because there's refugia and everything will come back. Deborah's book is a very, very discerning way of thinking about how to look ahead into the future in hope of refugia. And she draws in a great number of biblical resources and points out how these are stories of refugia in history of the Jewish and Christian narrative. So, how do I want to say this? Scientists who are really, really working with great scrutiny in their fields, they're not saying the world's going to come to an end. What they're saying is things are going to get really bad with varying kinds of probabilities. But they're not saying the world is going to come to an end. And that's why my paper, I argue that the Christian understanding of hope is that God brings about recovery and resurrection out of disastrous things, but God doesn't do it without us. That many things that people will do will not come to any obvious end, but the goodness that God can bring through people of hope is not going to happen if nobody has hope. So the doomsday scenario, I think you're right. It enervates people. It makes people give up. But there's something about the supernatural, what's called the supernatural virtue of hope, that says, yeah, I know things are bad, but I know God is calling me to do this, and I'm going to do it anyway. I'll leave it in God's hand to make the good out of it that only God can make out of it, but God can't make it out of it without me doing it.
Thank you.
Pat, I appreciate your clarification on, we're not going to destroy the planet's going to be here for another 5 billion years. I mean, we're not, but with the
And cockroaches also.
Yeah, yes. So, but the catastrophic, what's catastrophic for all the people and the biosphere in that time frame. But my view would be that it would be that because of the seriousness of the risk and it's not irretrievable. That is that once you've set this in motion, you can't go back. You can't bring this back. So that there's an intensity to our ethical responsibility that is much more than just continuing to do science and be hopeful that this happens. We're not doing so many things that we could do as a community, and largely just going on with our lives, which I don't think our students will think we're good people. I think they'll think we're pretty awful.
They already do.
What?
They already do.
You already think we're good people?
No,
That we're not good people?
you screwed us. You didn't do anything about that.
And I think that there's a way in which we have failed terribly.
Yeah,
And it's not about keeping what we've been doing more. I mean, I appreciate what you've done here, but that it's not continuing asking questions. There's an intensity and an involvement and an analysis that's necessary that we haven't done, and we're losing. We do have power. We're not doing the power things we need to do. We functionally just keep going on. And I don't see how that's just a grave complicity in mass death of human populations and mass extinction. And those doomsday scenarios are precisely the importance of, or those catastrophic scenarios are precisely the importance of ethics. Ethics comes in my judgment, in the scientific discipline of saying you don't have to have absolute certitude to operate under the precautionary principle. And ethics will allow them to actually do what they haven't done, IPCC hasn't done sufficiently, although I mentioned it was so important, is that to show us the low probability, high risk. So now we have abrupt climate change that's getting more, and it was off the radar of the wider public until probably a little past 2 years.
Yeah.
Anyway, that's...
Yeah, well, I can only do so much in the paper.
No, Pat, I thought it was great, and I'm just saying, I don't want us to just, I think there's just...
I agree with you. Okay, I agree with you. What I was doing in the paper was, first of all, meeting part of the invitation of this conference about the interdisciplinary and what Laudato Si and theology have to contribute to the sciences. The second thing is a big motivation for the book was the seriousness of climate change denial, and to address, how do I say this? To address that science and human action are not separate things, that they are integral, and that we don't think of them as integral. And there's a big part of the philosophical community that really says, well, facts and values have nothing to do with only values. Is just out here, it has nothing to do with fact. Well, that's just wrong, but it's not easy to say philosophically what's wrong with that. And it does have a kind of subtle effect of marginalizing what science has told us about our environment. What you're emphasizing is something I do more of in the book, which is what is the ethical response to that, and the ethical response is the big issue, the big problem. It's what's been undercut by climate science denial, it's just scary to see what has happened. I read that passage at the beginning of the book. Just incomprehensible what is happening in the new administration, which is fueling other people in other parts of the world to follow suit. That is catastrophic, and we need to know it's catastrophic because we need to stand up to the catastrophe. And you're absolutely right about that. And we need to think, as you said earlier, we need to think about critically about where are the points where we can do something, and to have a critical analysis of the situations where we can do something. That's absolutely right. My concern is that if all you get is the catastrophic accounts, that people will just give up. And what we need to do is awaken, the gift of hope that is a theological gift. And it's not easy to do that. And we've got great exemplars in people who, through the history of the Jewish and Christian traditions and other religious traditions, the history of religion in African American America. People who stood up with no way of predicting that anything good would come of what they were doing, and they did it out of hope. And so the pitch is really that hope is important, but it's not a hope that science will save us. That's not what I'm saying at all.
No. So I was in regards to the question, and I agree